All right, so back to school, had a lot of fun, went to the University of Akron. Yeah. It was kind of painful. I'll show you, I'll show you what I mean. Check it out. It's been a while since I stepped onto a college campus to go to class. Having the campus map on my phone GPS was supposed to help.
I downloaded the map to the school, and I'm trying to find where the dance class is. You know where dance class is?
They're in this building downstairs.
They're in this building?
Yes.
Oh, awesome. All right, are you going that way too?
Yes, I'll take you there.
Excellent. Because I got to go to dance class. Do I look like a dancer?
No.
A quick change and some painful stretching. It was off to the Streb dance class.
You activate all your muscle groups at once and you try to pop from one shape to the other without being predictable so we don't bend our knees. Dancers ready. Ready. And go.
And we did a lot of popping. We popped on our backs.
Crouch.
We popped on our stomachs.
And crouch. Into your back. And crouch. And perfect line.
Then we popped in a circle.
Go. Yes.
Then we popped and went popping crazy. Naturally, I got confused.
Crouch. Clump. Stomach. Very good. Back to your clump. And to your crouch.
It's a little jarring at first. It's really, you have to get used to the impact. But as long as you're not afraid of it.
After wandering around campus, I made it to the criminal justice class, and they were talking about...
You'd actually be able to tell where the person was standing depending on how these blood splatters...
After learning about fingerprints, bullets, and skulls, I found the real thing is not a CSI TV show.
Sometimes you can actually see the fingerprints. No, just brush it.
Oh, just brush it.
Brush it on. Brush it on, see if you can get them.
But all of my fellow crime-fighting students seem to really love the class.
I like the study of the criminal mind, like back to the root of why they do what they do. And then I like the on-scene, straightforward crime scene investigation.
So, back on campus, I was trying to find my way to the student center and then to physics class. The University of Akron campus can be confusing, but I found a lab coat and made it to my physics class. I knew I was out of my league when we went to transfer some liquid nitrogen.
Now that the container's a little bit cool enough, we can back off on the pressure so it doesn't burn us.
So we took the liquid nitro and did an experiment teaching me about the Meissner effect.
So right here, I have 3 superconducting wafers. Now what that means is that once we cool them below a certain temperature, they'll go superconducting. And we'll get a really cool effect where a magnet that's placed above these wafers will be expelled. Basically, it will hover above the superconducting wafers.
Okay, are you as confused as I am? But all of this makes a magnet float, and it looks pretty cool. Then another cool experiment explaining magnetic waves and what they do and what they might look like.
And if we trace out the entire page here, we'll find that it sort of comes out of one end and comes back and loops around to the other. As we move the compass around, it's going to keep swiveling around until it closes itself back up.
So now that I was thoroughly confused, I went to the brand new corrosion engineering class for some science clarity.
This is the aluminum substrate with the steel fastener that has corroded for 3 months.
They create corroded conditions on all types of metals, study them, and then find ways to create better material.
That's right. We get a reading of 1.3 volts, so that means there's a difference of 1.3 volts of potential between the 2 different metals.
Now, why is that bad?
This is bad because, say, there's a car or an automobile, and these metals are touching together if they're connected, and they're in an environment that has an electrolyte, such as salt water. You know, on the roadways, you have, in the wintertime, you have snow and there's salt on the road. It's going to create a corrosion cell, causing your less noble metal to corrode.
This is the only class of its kind in the world, and the pressure is on to create the new generation of corrosion-solving engineers.
The Department of Defense spends $22.4 billion a year fixing corrosion. And they said, we got to do better. And if we're going to do better, we need experts as well. So those two forces came together with a very dynamic university president. Luis Proenza is just a proactive guy. And he said, we'll do it.
With some of the brightest students in the country, I felt going back to school was harder than it sounded.